Hey guys, we're back for day 2 with the graphs. So if you remember our quadratic formula that we looked at the other day, okay, we said we were working kind of with the transformation form right now. And this is its form. Now yesterday we talked about the A. We said the A controls whether the graph goes up or down. The A controls whether the graph is going to get narrow or wide. Okay, so now today we're going to look at, well, what do the H and the K do? Okay, initially this is a discovery lesson, but obviously things have changed. So I did change it up a little bit from what was in the original packet I usually do in class. So again, what you need is still on there, but you kind of got to pay attention to the notes here too, because I did do things slightly different. Okay, so the first one you're given in example 1, you notice is y equals x squared plus 2. We're going to basically kind of do what we did yesterday. We're going to graph them and we're going to discover what they do. Okay, so if I look at this one, if you go ahead and put it in the calculator, okay, and again, for these first two, we're going to use the same set of numbers that we used yesterday. Okay, so we use -2 to +2. You'll notice your pattern ends up being 6, 3, 2, 3, and 6. Okay, which is a little bit different than yesterday, but we still have the mirroring going on here. Okay, so when you graph this one, so we've got -2, 6, -1, 3, 0, 2, and then it'll mirror it on the other side. Okay, first thing you might notice, this one's not at 0, 0. You're correct. Okay, the vertex does not have to be at 0, 0. Today it is going to change. Okay, so if we look at this one, this vertex would be up at 0, 2. It doesn't ask you to write that down, but just wanted to talk about it. Okay, your domain would be the same. Your axis of symmetry would still be x equals 0, because that would still be going through as well. Your range would change though, because this time we're going to 2 and we're going back up again. So for your range, it would be y is greater than or equal to 2 instead of 0 as we had yesterday. Okay, the next one as well you're going to notice is a little bit different. This time it has a +5, or excuse me, a -5. I changed that. Okay, so for this one you ended up with -1, -4, -5, -4, -1. Again, if you need to pause and put it in the calculator, please do so. Okay, so when you graph this one, we'll be at -2, -1, -1, -4, 0, -5, and then we'll be up the other way. Okay, so you'll notice the vertex for this one is down at 0, -5. Axis of symmetry would still be x equals 0. Domain would still be all real numbers. This time the range would have to be at -5. So it would be y is greater than or equal to -5 because it is going up. Okay, so you'll notice the first one we had the vertex up here. Second one we had the vertex down here. So as you look at that, you'll notice this number that we add or subtract to the end, that's going to either shift the graph up or shift the graph down. Okay, and if we look over here at this, that would be our K because it's not in the parentheses. Okay, so at the bottom of it, it asks you, okay, all of the graphs in example 1 were in the form y equals x squared plus k. How did the k transform the graph? It's going to shift it up or down. Okay, so if k is positive, graph shifts up. And if k is negative, then the graph shifts down. Okay, so it just moves all the points up or down depending on if the k is positive or if the k is negative. Okay, so that is what the k does. Okay, then last but not least, we need to find out what does our h do. Okay, so let's go ahead and look at the h now. You'll notice the h is in the parentheses. It always will be. Okay, if it's going to be an H, it will be in parentheses. If it's not in parentheses, then it's the K. Okay, so don't mix those two up. Okay, so for example 2, first one you got is y equals x minus 2 squared. Notice it's in the parentheses. Now this one is where you are not going to be using the same set of numbers. They are now going to change, okay, because of what's going to happen with the H. Okay, what you need to look for is you need to look for where you start getting that reflection, okay, where they end up being the same. So if you put this in the calculator and the y equals, okay, for this first one, if you look at the numbers 0, 1, 2, 3, and 4, you're going to notice a special pattern with the y's. Okay, you'll notice that it's 4, 1, 0, 1, 4. Okay, again, you start to get that reflection where they're the same. Okay, and that's what we need to have. So that's what you have to look for to pick the right set of numbers. It will not be -2 to +2 all the time. Okay, it is going to change. What you're looking for is the pattern of reflection or symmetry. Okay, so if we graph this one, I want to go 0, 4, 1, 1, and back again. Okay, so you'll notice that this one, everything was shifted to the right. Okay, so now our vertex would be at 2, 0. My axis of symmetry would be at x equals 2 now, because that's where it's going through. Okay, my domain would still be all real numbers. My range would be y is greater than or equal to 0, because again, you go to 0 and then you go back up from there. Last one we have here like this is +4. Okay, so again, you want to look for the pattern, okay, where they start to reflect themselves. Okay, again, it's not going to be at the same set of numbers. Okay, this time you should find it at -6, -5, -4, -3, and -2. Okay, this time I end up with -6, 4. -5, 1. So you'll notice that this one then is shifted to the left. Has a vertex of -4, 0. Okay, the axis of symmetry would be at x equals -4. Domain would still be all real numbers, and then the range would be y is greater than or equal to 0, because again, that's the lowest it gets, and then it goes up from there. All right? So as you can see then, this time it's shifted left and right. Okay, so the H is going to control the left or right, the K controls the up or down. Okay, so for this one, so if H is positive, now be careful, because this is actually opposite of what you think. Our H was positive here and it shifted it to the left. Okay, anything inside the parentheses is actually opposite of what you would normally think. So if H is positive, then the parabola shifts left. And if H is negative, parabola shifts right. Okay. So again, okay, going to have that left or right shift with the H. So just a quick review here then, because we're going to go into our last example, example 2 here. This one is not on the inked notes because this is a new one I just put on for you guys, since I'm not going to be able to answer questions and that type of stuff quite as easily as I normally can. I added one more example for you guys. All right, so the directions for your last example say, describe how each part of the function transforms the parent graph y equals x squared. So y equals x squared is considered the parent graph because it's as basic as we can get. Okay, no extra numbers, just the quadratic itself. Okay, so you'll notice here you've got two things happening. I've got a 3 and I've got an 8. Okay, and I got to talk about what they do to the graph. So if I were to put this in the calculator, I could know what it would look like without even having to do that. But you can always double check it in there. Okay, because this is attached to my x squared, that means the 3 is the a. Okay, so this would be my a. Okay, the 8 is not in parentheses, so that means that would be my k. So if we go back to what we talked about yesterday, the a controls two things. It controls which direction it opens, and it also controls if it's wide or narrow. Okay, since this is a positive 3, I would say that it's going to open up. 3 is bigger, the absolute value of 3 is bigger than 1, so I'm saying it's getting narrow by 3. And then the k we talked about either shifts it up or down. Because it's a positive 8, it would be shifted up 8. Okay, so that is the 3 transformation. So if you were to put it in the calculator, you should see that's what happened to your graph. It got more narrow, it would open up, and everything would be shifted up 8 spots. Okay, so that's what we want to be able to do, is just be able to look at the equation and kind of have an idea of what it looks like. The next one we have is negative x squared minus 2. Okay, so again, this is technically a negative 1. Okay, so that would be my a. This is not in parentheses, so again, it would be my k. So for this one, my a is a negative. That means it's going to open down. Absolute value of negative 1 is 1. 1 does not make it narrow or wide. I just don't write anything if it's 1. Okay? The negative 2 is going to shift it down 2. Okay? So that would be the shifts that would happen then for the second one. For the third one, we have 1/2 x minus 2 squared plus 3. Okay, so that means this would have to be my a, this would be my h because it's in parentheses, this would be my k. So the a is positive, so it's going to open up. It's 1/2, okay, which tells me it's going to get wider. A negative 2 for the h tells me that it's shifting right. And then the positive 3 tells me it's shifting up. Okay, so that one had all 4. 4 is the max of what you'll have, because the a controls 2 things and then these each control 1 thing. Okay, so you can have up to 4 different transformations when you are working with these graphs. Okay, so right now, why don't you go ahead and pause this. Okay, do the last one, see if you can get it, and then you can double check it with us here. Okay, so for the last one, okay, this would be an A and this would be an H. Okay, so because it's a negative, it would open down. Absolute value of negative 2 is positive 2, so it would get narrow by 2. The positive 7 on the inside would move it to the left. Okay? And that again, if you graph it, you could double check to make sure you did it correctly. All right? So your homework is going to be a worksheet today. So make sure you either print it or do it on notebook paper. Doesn't really matter to me. Big thing is that we're learning and we're understanding. So you can build on this stuff over the next couple years in geometry and then also in Algebra 2. All right? Have a great rest of your day.